Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the sum of interior angles of polygons. Here are the lesson objectives. By the end of this lesson, you should be able to recall the sum of interior angles for a triangle and a quadrilateral. You should also be able to derive the general formula using triangle splitting method. You should be able to calculate the total sum of interior angles of any polygon at all. And finally, using the examples we'll be solving, I expect you to be able to find the size of a single interior angle of I expect you to be able to find the size of a single interior angle in a regular polygon. So without much ado, let's quickly look into it. So we want to start by looking at the sum of interior angles of a triangle. We all do know what a triangle is. It is a three-sided polygon. So this is an example of a triangle. We know there are so many types we have spoken about in our previous lessons. But how do we get to know that if we are to add all the interior angles, so if we add this and then this and that, how do we get to know that their sum gives us 180? This beginning is just going to be a short proof on that. So first of all, we do know that if you take a straight line, the sum or the angle it makes is what? A 180. So what I'm going to do is I'm going to split this triangle into the three angles that make up this triangle and try my best to align them on this straight line. So with this first one here, I'm going to align it so that it appears this way on the straight line. And I'll take my second and then also make the same alignment. So let me just change the color of this. So as you can see, I'm doing that again. So as you can see, we have it perfectly fitted over here. You see. So that is it there. Then what happens to this last one? Let's see if it is also going to fit over here. You see that? So we have taken the three sides of the triangle or the three angles that make up the triangle and it has fit into what? It has fit on this straight line over here. So what have we done? We've actually established the fact that for a triangle with these angles, A, B, and C, if we are to sum them up, that is A plus B and then plus C, we are actually going to get what? A 180 degrees. We have proved that the sum of interior angles of a triangle is equal to 180 degrees. Now, this idea we have is going to help us generate a formula. But before we do that, let's also take a quadrilateral. Now, for a quadrilateral, if we take all the interior angles and we sum them up together, we know it's equal to what? 360. The quadrilateral can be a rectangle or a square, a parallelogram, trapezium, and what have you, any of them. You see. So to prove that, we are going to do that just as we did with the triangle. So I'm going to clean this side so that we focus on the four angles that make up the quadrilateral. You see. So all I'm going to do here is to turn them. So I'll turn this one around and also turn this around. Now as I turn, I'm just going to align them so that they stand or they are aligned. So I'll turn this also around. And then finally turn this also around. So I'm just going to turn it this way and put it here. Now what do you see? You realize that all the angles have aligned together to form a what? A 180. To form a what? A 160 degrees. That is a complete circle. So with that, if our angles were an A, B, C, and then D, then we can also say that if we sum up all the interior angles of a quadrilateral, they are going to get a 360 degrees. Now, what of the other polygons? So let's say a pentagon, a hexagon, heptagon, octagon, nonagon, all the gons. How are we going to determine the sum of their interior angles? There's a very fast or simple formula we use. So the formula we use to determine the total or the sum of interior angles of a polygon is given by what? N minus 2 times 180. How do we get this formula? Let's derive it. So first of all, we know very well with these proofs how we derive what? The sum of interior angles of a triangle and that of a quadrilateral. Now let's focus on the triangle. So this is the triangle. You see, it is just one triangle. And we know the sum of interior angles of it is what? 180. So what if there are two triangles? There are two of them. So let's just copy this triangle here and then paste another one so that they become two. So all I'm going to do is to rotate it so that it looks like this. Now in my rotation, what have I formed? I've actually formed a quadrilateral. You see, so if I'm to take these two out of here, it is a quadrilateral in disguise. You see, so there are two triangles in a quadrilateral. So if I know that triangle is made up of the sum of interior angle is equal to what? A 180 degrees. And now I have two of those triangles. Then to get a quadrilateral, it is the same as multiplying it by what? Multiplying the 180 by 2. And that is what we use to derive what? The sum of interior angles of a quadrilateral. Quadrilateral having the size of 4. Giving us what? 360. You see? So a quadrilateral is of 4 sides. What of a pentagon? So with this trick now, this we have here is actually a pentagon. A pentagon because it has 5 sides. So 1, 2, 3, 4, 5. And looking at how we're able to derive that of a quadrilateral, that is looking at the number of triangles we had in there. So trying to determine the sum of interior angles of a pentagon, we're actually supposed to add all of these interior angles. So we'll add this to this, to this, to this, and to this as well. But then there is a much better way, just as we did for this quadrilateral. So let's determine the number of triangles we have in here. A triangle has 3 sides. So 1, 2, then let's extend this to this. You see, use a straight edge. So let's extend this to this. That is 1. So we have gotten 1 triangle. Then the second one, let's extend this line all the way to here as well. You see, so in total, how many triangles do we see? We have 1, a 2, and a 3. You see, so since we have 3 triangles, we know 1 triangle has what? Sum of interior angles being 180. Hence, we can say for this pentagon, you know a pentagon has what? 5 sides. Then the sum of interior angles is actually going to be what? 1, 2, 3. So 3 of the triangles, 1 of the triangle is actually a 180. So if we multiply this, we are going to get what? A 540. So we can simply say it implies that the sum of interior angles of a pentagon is what? 540 degrees. Now we'll do one last one, and then from this last one we'll derive a general formula. A general formula that will help us determine, even if we are talking of a decagon decagon or a duodecagon. So for the last proof, we're actually going to use a hexagon. So this is a hexagon, and we want to determine how many or what is the sum of interior angles. You see, so using the, take note, the method we are using now is called the triangle splitting. So you're actually splitting the pentagon into triangles. You see, so how many triangles can we split this into? We have the first triangle, we have a second one, and then we have what? The third one. So there's 1, 2, 3. There's actually 4 triangles. Okay, because when we divided this into 2, we had 2 triangles from that. So 1, a 2, a 3, and a 4. So for a hexagon whose side is equal to what? 6, then the sum of interior angles is equal to how many of the triangles? 1, 2, 3, 4. So 4 times of a triangle. You see, and 4 times 180, we are going to get a 720 degrees. So what do we say? It simply implies that the sum of what? The sum of interior angles of a hexagon is 720 degrees. And that is just it. So now that we have done to the hexagon, we want to get a general formula. So let's start first of all with what? The triangle. For a triangle, we have what? N sides. So the n is what? 3. And for that, we just multiplied 180 by just 1. And that gives us a 180. For a quadrilateral has 4 sides. And what did we do? We multiplied the 180 by 2. You see, and that gave us a 360 degrees. For a pentagon has 5 sides. We had to multiply the 180 by 3. And that gave us what? A 540. And for what we just did here for the hexagon, a hexagon has 6 sides. So we had to multiply 180 by 4. And multiplying it by 4 gave us the 720. So what do you see? The number of sides minus 2 gives us what? The multiplier over here. Hence 3 minus 2 gives us the 1. 4 minus 2 also gives us what? The 2. And we have 5 minus 2 giving us a 3. 6 minus 2 giving us a 4. So we can say that if we are to continue, then for any polygon of n side, we need to use n minus 2 and then multiply it by 180. After which, we will now get what? Our result over here. So the general formula for the sum of interior angle of any polygon at all. You can say the general formula for any polygon of sides n is given by what? N minus 2 then times 180. As simple as that. This is how we derive the formula using splitting triangles. So with this formula, let's now solve some questions that will require us to what? Solve for the sum of interior angles without drawing. So for our first question here, it says find the sum of interior angles for a 7-sided shape. That is a 7-sided polygon. And we know a 7-sided polygon is a heptagon. So with this, we want the sum of interior angles of the heptagon. As we said, we are not going to draw. We just write the formula. The formula says sum of interior angles equals what? N minus 2 then times 180. So let's write that down. So with our formula written, we then determine what our n is. So we know our n is equal to what? 7. So it simply implies we have what? 7 minus 2 then times the 180. 7 minus 2 gives us a 5. So we have a 5 times 180. And 5 times 180 gives us a 900. See? So it simply implies that the sum of interior angles of the seven-sided shape is 900 degrees. So you finish with your conclusion, and that will be all. Let's solve one other question. It says find the sum of interior angles of a decagon. Now you know what a decagon is. A decagon is a polygon with what? 10 sides. So since we want the sum of interior angles, write down our formula. So the formula simply says the sum of interior angles of any polygon is given by n minus 2 then times 180. So in this case, our n is now a 10. You see, so substituting, it simply implies that we have a 10 minus 2 then times the 180 degrees. 10 minus 2 gives us an 8. So we have 8 times 180 degrees. 8 times 180 gives us a 1440. You see, so it simply means the sum of interior angles of a decagon. If we add all the interior angles of a decagon, we are going to get what? 1440. Now it is important you take note that since you now understand and know how to find the sum of interior angles, the questions can be twisted such that you'll be given the sum and then you'll be asked to find the number of sides of that polygon whose sum you've been given. So with that, let's look at how we solve such questions in this next example. So looking at our last question here, it says a polygon has an interior sum of what? 1800 degrees. How many sides does it have? How many sides does it have? This question has actually already given us the sum. Hence what we want the n. Now as always, we know our formula, which says the sum of interior angles is equal to n minus 2 then times 180. Meanwhile, we've already been given the sum of the interior angles. So I'm going to say that the sum of interior angles has already been given to us and its value is what? 1800. But what do we want? The n is what we don't have. You see, so it simply implies that our 1800 is equal to, that is the sum of interior angles, is equal to the n minus 2 then times our 180. This has now become a problem of what? Change of subject. So we want the n to become the subject. Now since what is going on here is a multiplication, then we can straightforward divide both sides by 180. So divided by 180 and then divided by 180. Where we can say this 180 divides this 180 to give us 1. And then for this, we have 180 dividing 1800 10 times. So this simply implies that we are going to get 10 here, which is equal to an n minus 2. We still don't have our n. Hence, let's add 2 to both sides. So we have 10 plus 2 is equal to n minus 2 plus 2. And these move out to give us 10 plus 2, which is a 12. So 12 is equal to n. Hence, the polygon in question has 12 sides. You see, so we have just applied a little algebra and change of subject, cum the knowledge we have on angles to get the number of sides. In an actual sense, it is a duodecagon, right? That is a polygon with 12 sides. So with these formulas understood, you should be able to solve any problem, especially if you understand your algebra and then change of subject. You are just going to apply these formulas. As usual, I'll leave you with some exercises just to test your understanding. If there's any issue of concern, you can always let me know at the comment section. So here you have just 5 questions based on what we have done in this lesson to test your understanding. We end this lesson here. Now this is how Beyond Numbers, where we learn maths the easy way. If this was your first lesson on this channel and you think it will be of help to you, you can subscribe if you so do wish, so that anytime I release a video, you'll be notified as well to come and then learn with us. See you in our next lesson, and bye for now. Stay blessed.